3, 2, 1, lift off. With the countdown at 2:35 p.m. on 14th July 2023, a decisive hope enveloped every Indian or a person of Indian origin. Mission Moon shall be a reality now. Unmanned Chandrayan-3 is one of the most ambitious celestial projects undertaken up till now by ISRO, Indian Space Research Organization. Till now, 11 countries have earmarked on 144 missions to explore, understand, and research the moon. Of these, 95 attempts have been successful fully or partially. 49 attempts by varied countries have failed till now. Till now, it's the United States of America that has been the only country in the world to land a manned mission on moon in 1969 via Apollo 11. Countries that have soft-landed objects on moon are the USA, Russia, and recently China. Countries which have landed objects on moon include India, China, Russia, and America. And countries that have successfully landed or are seeking to explore the moon's surface are Israel, South Korea, Japan, India, China, Russia, United States, and a host of other countries. On August 23rd or 24th, when Chandrayan-3 and its lander would touch down at 70 degrees south of South Pole of Moon on a tiny patch of 4.2 kilometers by 2.5 kilometers and release the 26 kg rover to explore and conduct experiments on lunar surface, India would have become the 4th country in the world to have achieved this feat. Mind you, till now, in the history of lunar exploration, none of the expeditions have landed on the south side of the moon. Now let me explain this further. The visible side of moon from Earth is the north side or the central or the equatorial portion of moon. All landings till now of objects, manned or unmanned, have been on this phase of moon as the surface data of the moon's equator or the north side is readily available. We are a range of satellites which we today have, plus the radars. But it's the dark side of moon, away from Earth's line of vision, home of massive surface inundations such as huge mountains or craters, which holds the key of lunar exploration. The hill peaks which are here on this side of the moon could have temperatures as high as 54 degrees Celsius, while the craters could have temperatures as low as minus 200 degrees Celsius. It is this south pole side of moon that our previous mission, Chandrayan-2, and now Chandrayan-3 is set to land. And if Chandrayan-3 and its lander touches down successfully and releases the rover, India would then become the first country in the world to have etched its own record. Conceptualized and announced in 2003 from the ramparts of the Red Fort by the late Prime Minister Atal Bihari Vajpayee, Chandrayan-1 was successfully launched on 22nd October 2008 under the tenure of Prime Minister Manmohan Singh. It was mounted on PSLV-11 rockets. This was India's first attempt and it was a resounding success in placing Chandrayan-1 within 100 kilometers of Moon's orbit. Apart from various sonographic experiments, enhanced map studies and other experiments, Chandrayan-1 established for the first time in lunar research done on Earth till now and confirmed the presence of ice water on the surface of Moon. This landmark finding established the fact that Moon could be inhabited by humans someday in future. On 22nd July 2019, India saw the launch of Chandrayan 2. It was a very ambitious mission, 48-day mission, flanked with orbiter, lander and a 27 kg rover, which is scheduled to land 70 degrees south of South Pole of the Moon on a tiny targeted patch of 500 meters by 500 meters. Following the loop technology, which is now also being used for Chandrayan 3, which I'll explain later, the lander successfully detached itself and was about to land on the surface of Moon when it was discovered that the lander has actually missed its target of a targeted patch which extended between 500 meters by 500 meters. In the absence of any prior ground data, because Chandrayan 2's lander was landing on the southern side of the Moon, the lander had been programmed in such a way that it would use live images to appropriate its own targeted landing. Since the thrust rockets, which are 5 in numbers, could not reduce its landing speed, the lander had to simultaneously also shift itself to a safer landing. There was a problem. Let me explain this in the layman's term. The lander rockets were firing itself to decelerate the fall, to reduce the acceleration, while at the same time, the thrust rockets were firing itself to maneuver the lander into extending its flight so that it could launch itself and land at the designated 500 meters by 500 meters patch. It couldn't happen. There was a miscalculation with the speed, and therefore the rover crash landed. The lander which crash landed could release the rover, and it did survive to send us a huge amount of surface information and images. But there were 8 experiments which it had to conduct. The rover failed to do so. But it sent us some real-time pictures of the surface of Moon, which is now of immense help for Chandrayan 3. Learning from this experience, Chandrayan 3 was designed with a substantive improvement. Launched on 14th of July 2023, Chandrayan 3 has taken to the skies mounted on a launch vehicle Mark III rockets. These rockets are very special. It weighs 650 tons with solid and liquid propellants. It is about 43.5 meters in height, which translates into 142 feet. LVM-3 placed the Chandrayan 3 into Earth's orbit in 963 seconds flat, which is about 16 minutes at an altitude of approximately 180 kilometers in space, acquiring a speed of 36,000 kilometers per hour. Hereafter, the Chandrayan 3 would revolve in loops just like Chandrayan 2, and it could make 5 or 6 loops of the Earth. Now the question is, why should Chandrayan 3 circle the Earth so many times? It's a very simple explanation. The Chandrayan 3 would be using Earth's gravitational pull to generate velocity so that it can shoot itself off to the Moon and cover a distance of 3,84,400 kilometers. But why should we not shoot a rocket straight to Moon, just like it was done for Apollo 11 in 1969 during its manned mission? That's precisely because Apollo 11 was a hugely costly affair. The total cost of Chandrayan 3 is approximately 620 crores. Compare that with Apollo 11, zero comparison. It pales in the comparison. Apollo 11 was using Saturn V rockets, which carried huge amount of solid and liquid fuel. Its height was 363 feet. Its weight thrice that of the LMV-3. So compare the LVM-3 or the cryogenic rockets 25 with Saturn V. So Saturn V stands at 363 feet. LVM-3 stands at 142 feet. So that's why we are using Earth's gravitational pull to launch Chandrayan-3 into the lunar orbit. Now once Chandrayan-3 reaches the lunar orbit, it can crash land. So it's again going to use the same loop technology to gradually reduce its speed. It will loop the moon 5 to 6 times so that the Chandrayan-3 can finally place itself into the 100-kilometer orbit before the lander detaches itself. This tech was successfully used in Chandrayan-2 and it will be again used in Chandrayan-3. Chandrayan-3 also has a 48-day mission. The lander of Chandrayan-3 weighs approximately 1,750 kilos, of which the rover weighs 26 kilos. The lander has 3 other payloads as well: the lander Doppler velocity meter, lander altimeter with its legs, and lander hazard detection avoidance camera. And it is expected that the lander would land on the surface of Moon on the South Pole side on August 23rd, or worst case scenario, August 24th. From August 23rd, the lunar day dawn begins. Now mind you, one lunar day is equivalent to 14 Earth days. So the 3 payloads and the rover are prepared and programmed to function for 14 Earth days or 1 lunar day, and thereafter, if it survives 1 lunar night, which is equivalent to 14 nights, Earth nights, and a temperature of minus 100 degrees Celsius, it could again be utilized. But the chances of reutilization of the rover after 1 lunar night are very slim. The lander payloads would study the surface plasma density, thermal levels, seismic activities, while the rover is mandated to conduct chemical analysis of the lunar surface. It will be looking out for mineral compositions and exploring for minerals which are present on lunar surface. Minerals such as magnesium, silicon, calcium, titanium, iron, aluminium, etc. Apart from it, the scientific research which rover is expected to conduct, rover will be doing something which we all do very eagerly when we reach a place of reckoning. The rover would be taking a few selfies of itself along with the lander. It will be a reminder that the rover has been there. It's almost as good as us taking selfies, right? Now let's look at the reason of this entire endeavor. Why are we hell-bent on making a mission moon so successful? Science and scientific research, space, intergalactic research, celestial know-hows have been the pursuit of mankind for years, rather decades, centuries. But for nations, it is a matter of national interest. Just as exploration of the forgotten continent Antarctica was once a scientific desire, but then the nations led the research to mark their presence and their territories. You know, Antarctica has defined territories for the US, Russia, France, China, and also India. In the eventuality of a future mining or land acquisition on the moon, India will have marked its own stake on moon itself. That's why it's very important. Now just compare the situation. Because Antarctica has been marked by various countries and portions have been defined, China recently came up with a concept that it desires to mine Antarctica for rare materials. Similarly, when technology permits, maybe the search for minerals and rare minerals take us to the moon. At that point of time, India will have its own stake. Or rather, when the world comes together to put up a moon station, India would have a decisive stake and demand its own logical rights. It's not too distant in future that both mining of moon or setting up of a moon station for further space research is not a very distant reality. It's underway. Can India afford to be behind this? Now, secondly, the other important question. Why do we need mission moon? Space exploration and the tech involved with propulsion technology, launching of satellites, space tourism, space defense. These are all areas which are getting massive venture funding. Point to be noted here. 4 years ago, India had less than 10 startups in the space sector. Today, we have more than 140 startups and the numbers are growing exponentially. Let me quote last year's figures. That is 2021 and 22. $121 million of venture funding have found its way with Indian startups. Skyroot Aerospace is a Hyderabad-based company specializing in launch vehicle designs. It has raised $68 million in funding just last year. Pixel has got $25 million as funding for space imagery, which finds its wide use in disaster management, mapping and crop sciences. Agnikul Cosmos, it's a Chennai-based startup which is working on cryogenic technologies used for launch vehicles just like the Fat Boy LMV-3 in Chandrayan 3. It has raised $35 million of funding in the last year. Bellatrix Aerospace, a Bangalore-based startup, is helping build a $76 million R&D facility for space taxi. Another startup, Dijantra, which is based in Bangalore, has raised $12.6 million to build Space Map. It is something like a Google map for space. This is just the beginning. The potential stands at multi-billion dollar for Indian firms and startups. Did you really know that Larsen & Toubro, L&T, a private Indian company known for its constructions, is a proud partner in Chandrayan 3? Just like Elon Musk's SpaceX or Blue Origin of Jeff Bezos, which makes rockets, or Richard Branson's Virgin Galactic, promising space tourism. These commendable feats have been achieved with the cost-effective, technological superior efforts of ISRO. And Indian companies are piggy riding on this success because ISRO has a success rate of 95%. Imagine where Indian space tech would be after Aditya L1 to study the sun's corona and chromosphere is successful. Where Indian tech would be when the participation in XPOSAT, a space observatory to study cosmic X-rays, finalizes itself in 2024. Or when the Mangalyaan mission Mars, the Mars orbiter, which was launched in 2013, enters the Mars orbit in 2025. Or for that matter, just imagine when in 2025, India plans its first manned space mission called Mission Gaganyaan. Chandrayan 3 today stands out amongst one of the most hard-fought endeavors of ISRO to harness space tech as the proud moment which can be tagged as made in India. It is this Indian capacity to demonstrate to the world that made in India space technologies would be helping immensely world over, that the world would now be investing heavy amounts of money into space tech development in India. India prides itself by calling itself the Vishwaguru. It is this path that we follow today in space technology. After all, we were the first to discover the value of zero. We were the first to understand astronomy. We were the first to understand planetary movements. While we used it for astrology and astronomy together, the world now comes to this realization. It is this feat that Chandrayan 3 promises to achieve for us. Thank you.